All right, so continue with concentrations. We're going to talk about making dilutions and what concentrated solutions are today, a little more. So we'll just get started. So there's a couple vocabulary terms that I might talk about as we go through. And you've probably heard most of them before. Saturated, right? When something is saturated, it's containing, or the solvent, the solvent is holding as much solute as it can. So if I try to add any more solute to a saturated solution, it precipitates or it falls out as a solid in solution. When the air is saturated with water vapor, if any more water vapor comes in, it precipitates or it rains or it snows or hails or something like that. So that's what saturated means. So if that's saturated, obviously unsaturated would mean I could still dissolve more solute in it, right? So if I have a cup of iced tea and I start stirring sugar in it, right, at the point where I can't stir any more sugar, and I just see sugar on the bottom, then I have a saturated solution. We'll talk about it. There's a thing called supersaturated. Which means holding more solute than theoretically possible. Soluble means I have a solute that's able to dissolve in a solvent. So ionic solids dissolve in water because water is polar, right? And then insoluble would mean a solute would not dissolve. So non-polar solutes do not dissolve in polar solvents. An example of that would be oil will not dissolve in water. Right? So they're insoluble. And then standard solubility, which you'll need for your lab. So standard solubility is expressed in grams per 100 milliliters of water or 100 grams of solvent. So essentially the same thing for us. So you have to remember that. Right there. Okay. So per 100 grams, so this is grams of, keep losing my pen. Grams of solute per 100 milliliters of solvent. If it's not water, then it's 100 grams. But I'll just 100 milliliters. So we've done what we have to do to get ready to do some dilutions. So a dilution is making things less saturated. So dilute means far from saturated. Concentrated means close to. So when we do dilutions, we're taking a concentrated stock solution, we're making it into a usable amount. So I like the formula over here. So C stands for concentration, and V is volume. A lot of times in chemistry books you'll see this one, and M stands for molarity, and V for volume. So the C is a little more useful because C could equal molarity, it could equal molality, it could equal percent, or in the biotech industry we use times. So if it's 50 times concentrated, right? And I want to make it a 3 times concentrated, that X means the concentration. So C is much more useful because no matter what it is, right, you can use C. So get my pen working. All right, so no matter what it is, you can use C. All right, so I like C better. So I'll show you some easy problems, and they show you a couple different ways of doing stuff. Right, so how much solvent is required to dilute 100 milliliters of 12 molar stock HCl to 3 molars? So remember, our formula is C1 V1 is equal to C2. Oops. So that's our formula. So we'll come back and solve this. So my concentration 1 is 12 molars. Volume 1 is 100 C2, which is 3.0 molars, times V2. Alright, so if I do this problem, I can cancel that out. I can put it under here, and I get 400 milliliters. So be careful. That's not the answer, because this 400 is the final volume. So it says how much solvent is required. So I have to dilute this 100 to 400. So I need 300 milliliters of extra solvent, because I've got to dilute it up to 400. Okay, so that's how you do that. So there's another way to look at it. So how much of a 50 by solution is required to make 250 of a 1 by? Alright, so here we go. So same sort of problem. So let me get it here. So we're going to use that same formula right here, the C1, V1. So my C1 is 50 by. This time I don't know my V1, so I'm going to leave that here. Is equal to C2 by 250 milliliters. So again, I'll cross that out. I'll write that down here. And my V1 then would be 5 milliliters. Okay, so not that hard to do. So I do 5 milliliters of my stock solution. And then I'd add 245 milliliters of water, and it would make it 1 by. Okay. All right. So another way to look at it: 250 milliliters of 25% solution is diluted to 750 milliliters. So again, I'll use my C1, V1. Right. So my C1, I have 25%. That's my concentration. 250 milliliters. C2, I don't know. And I've got 750 milliliters. Again, I'll go ahead and move that over here. I get 8.3%. So that's my new concentration. Okay? So 3 ways to look at problems. So for the lab you're doing this week, you're going to be using solubility curves. So this picture shows a solubility curve. So a couple things to take note of over here. You see that that's grams of salt and 100 grams of water. Remember, water is 1 milliliter is equal to 1 gram. So it's grams of salt and 100 milliliters of water. And this talks about solubility at a particular temperature. So if we look at room temperature, right, and we look at sodium chloride here. So room temperature is about 25 degrees. So right there, in the middle, so I can dissolve about 34 grams of salt, NaCl, right, at about 25 degrees. If I want to dissolve 40 grams of salt, right, then I'm going to have to come all the way up here to 100 degrees. So that tells me. So when we talk about temperature and solubility, so temperature, important to know, so temperature increases increases the solubility of solid solutes. If you look at a different example here, right, at room temperature, if we look at NH3, right, so at room temperature ammonia, I can dissolve about 50 grams of ammonia at room temperature. But if I come up to 100 degrees, right here, right, I can dissolve less than 10 grams. Right, so it's important to know it decreases. Get error. Try that again. So it decreases solubility. So ammonia will turn into a gas as it's heated, and that's why it decreases its solubility. All right. If I was to try to add, well, let me put it another way. So if I had KCl right here, so if I had KCl right here, right, at 80 degrees, right, I get 50 grams. So if I had 50 grams and I heat it past 80, and then I cool it to 60, and precipitate hasn't fallen out, this is now what we call supersaturated. So I can make a supersaturated solution by heating a solution up, dissolving solute in it, and then slowly cooling it down to where my solute is above the theoretical saturation point. That would be supersaturated. That's how you make rock candy. All right, so for your lab, a couple other things that you need to know about. Factors that affect the rate. Remember, rate right here is how fast something happens. So temperature, and we'll give you these generalizations for solid solutes. So temperature increases rate. By adding kinetic energy. Right? So for solids, if I increase the temperature, I increase the rate of solubility. Surface area. So grinding. So as to make particles smaller, right? It increases surface area. So this increases, right? So it increases rate by increasing surface, and stirring increases rate. By adding kinetic energy, just like the top one. Okay, so both all those. If I had a gas solute, right, temperature would decrease the rate because gas would be leaving. Surface area wouldn't matter because the solutes aren't touching, or the molecules aren't touching, and stirring would decrease. So gases are opposite. All right, so pretty quick this time, and then I'll talk to you soon. Good luck.